Good morning, our class, and welcome to this morning's discussion on some examination questions. JAM, WAEC, NECO, screening, JUPEB, NACTEL, and the rest of them. There are questions that at times are called up on quadratic equation to solve with students, which in reality are very simple, but students find them difficult to smartly arrive at what they were expected to do. So today we have decided to come and draw some of those problems up from examination past questions and then solve with our students. Today what we have on the board is this one. They say if the roots of x raised to power 2 minus 7x plus k equals 0 are m and m minus 1, find the value of k. Find the value of k. Find the value of k. That is the question they ask here. This is actually a JAM question drawn from the previous years. Then there are two things that first of all we need to tell our students, especially when they are confronted with questions like this. Those two important things are: one, you have to recall for yourself the general expression for quadratic equation. And secondly, you need to remember that equation which you arrive at when you are given two possible roots of quadratic equation and you are asked to use them to come up with the quadratic equation. We are going to remind you them on the board here, but we now beg you that you keep those things now at the tip of your hands. The moment you see questions around this area now, recall those areas now and move towards that direction. You might likely now come up with the answers with the knowledge you are going to apply from those areas. So let me now remind us. As a way of solution now, I'll put solution here. As a way of solution. So permit me to divide the board as usual. So the general expression for quadratic equation is given as a x raised to power 2 plus bx plus c equals 0. This is general quadratic expression. And then if you want to make the quotient of this x raised to power 2 to be 1, you are going to divide all the terms in this equation now with the letter a. And by doing so, what you are going to have here becomes what? You have a x raised to power 2 all over what? A plus b x all over a plus c all over a equals 0 all over a. And in that note, this can cancel this. And then what you are now going to have left now becomes what we call x raised to power 2 plus b all over a of x plus c all over what? A equals what? 0. Reason being that 0 divided by anything will return back what? 0. So this is also general expression for quadratic roots because we arrived at it from making the quotient of x raised to power 2 here to be what? To be 1. Important question to note. Now, the second equation you are going to remind yourself is that one I told you that when you are given two possible roots of the quadratic equation, alpha and beta, you are asked now to arrive at the values. And that equation is, you have x raised to power 2 minus, open a bracket, alpha plus what? Beta of x plus what? Alpha what? Beta equals what? 0. This is the equation you arrive at when you are given the two possible values of the quadratic equation, alpha and beta, and you are told to use it to generate the quadratic equation. You have this. And when you have this, it is clear that this is equal to the quadratic equation. So we compare this quadratic equation with this quadratic equation, term by term. Comparing them term by term, I mean this is x raised to power 2, it should be equated to x raised to power 2. This is what? X raised to power 2 should be equated to x raised to power 2. Then we now come, the second term is now this and this. So we are going to equally equate this to this. equating this to this means I have b all over what? A, that is b all over a of x equals. What I have here is minus alpha plus beta x. So I have minus this alpha plus what? Beta of what? X. At this point in time, there is what we have here and what we have here that can cancel off. X can cancel x off. So you have this and this is cancelled off. And then of course, this thing now can be written as that this thing becomes what? Alpha plus what? Beta now is given as. This minus will come and affect this one. You have minus what? B all over what? A. This is what you are going to have. So with this, which we now have now, we now return back to the question that we were given. The question we are given said x raised to power 2 minus 7x plus k equals what? 0. So what we are going to do now is to begin to compare 10 by 10 of this equation with these two equations. Here is my x raised to power 2. Here is my x raised to power 2. Here is my x raised to power 2. Then I return here. Here is my minus 7x. Here is my b all over a of what? Of x. Okay. So the only thing now, look at this x here now. Look at this my x here. Which means this my b all over a is given as minus 7. Look at my x here. Look at my x here. What I have as the quotient of here is what? Minus 7. So the equation here is b all over a. Which means this my b all over a is given as what? Minus what? 7. And remember that this my b over a here, of course, have been equated to this. So what I'm now going to do now is to come here and say, therefore, this my alpha plus what? My beta is given as b over a. This is giving me, this is what? I have what? This minus has been in the equation. So I have my minus. This one is what? Minus what? 7. We move. However, if you check, we were not asked, we were not told that the roots are alpha and beta. We are told that the roots are what? M and m minus 1. So in place of this my alpha, I'm going to use m. In place of this my beta, I'm going to use what? M minus what? 1. So which means this thing now becomes what? Here it becomes what? My m plus. This my beta becomes what? M minus what? 1. This is equals minus minus in mathematics means plus. So what I have here becomes what? 7. So in that case, I will have m plus m will give me what? 2 what? M minus 1 is equals what? 7. Then taking this one over there now will imply that my 2m equals what? 8. That is this one going over to join that 7. So making m to stand alone all over what? 2 all over 2. This and this is cancelled off and m equals 2 here is what? 1 and 2 here will give me what? 4. So I have known that the value of what? Of m is what? Is 4. And remember that what we are asked to find is what? Is k. And this minus what? 7 stands as what? At the sum. Look at where the sum is. Here is the position of what? Of k here. And k is talking about what? Product of the roots. The first term here is x. Look at the x. The second term here, which is here, is talking about sum. The third term here, which is k, is talking about the product of this root, which is alpha, beta. And then the roots are what? M and m minus 1. And I've known that my m is what? Is 4. So for me to get m minus 1 now, so m minus 1 is going to be 4 minus 1, which becomes what? 3. So product of this root, which is now my m into m minus 1, is the same thing as 4 times what? 3, which is equals what? 12. So the value of k, which they want me to find is what? Is 12. You see how simple that this thing could be. The only thing you need to remind for us is what? Is this and this, this and this. The moment you have these two things at hand now, you will get definitely very, very far. So permit me to clean this board now while we call up another question to solve with you. But as we are doing that, we are going to paste these two equations somewhere on the board so that every other equations we are given, we keep comparing them with these ones. Okay. Okay, let us try and look at this one equally. This one is given as this. This one is given as this. Number 2. Okay, but before we solve that thing, we say we are going to place that thing on the board. This is x raised to power 2. Then we have a plus b all over a of x plus c all over a equals 0. And we had x raised to power 2 minus alpha plus what? Beta of x plus what? Alpha beta equals 0. These are the two equations which we must always remember. So here we have if alpha and beta are the roots of 2x raised to power 2 minus 6 what? X plus 5 equals 0. Find beta all over alpha plus alpha all over beta. That's the problem that we are to solve. So if alpha and beta are the roots of this particular thing, we should find alpha over beta plus beta all over alpha. So that's exactly what we are going to do here. The most important thing we are going to remind ourselves is just how to, first of all, how to find alpha, and then how to find beta here. So as a way of solution, first of all, we have this. So here we have solution. So we now, first of all, you are going to transform this equation you are given to look at these things. Looking at these things means you make effort to make sure that the equation is what? Is 1 of x raised to power 2. And if you come here, the equation is not 1. So we must make effort to make the equation to be 1. So by making the equation to be 1 here, we are going to divide all 2 with what? 2. And this equation we have now becomes what? 2x raised to power 2 all over 2 minus 6x all over 2 plus 5 all over 2. This equals to 0 all over 2. So that this can cancel this. And we are left with x raised to power 2 minus. Of course, in this case now, this can cancel this, but let us leave it like this in order to cause confusion. 6 over what? 2, in order not to cause confusion, of x plus 5 all over 2 equals 0. Because when anything divides 0, it will definitely come back as what? 0. So with this now, we can be comparing this with this and with what? This. And based on what we evaluated earlier, we know that based on what we had earlier, that alpha plus what? Beta is given as minus what? B all over what? A. That was what we had. So we now want to compare this with this. Comparing this with this is my x raised to power 2. This is my x raised to power 2. This is my x here standing. The quotient of this x is what? B all over what? A. Look at my x here standing. The quotient of this x here is what? Minus 6 over 2. Because we are comparing this equation and this equation 10 by 10. So by implication, B all over A is given as minus what? 6 over what? 2. So in that case, I will categorically come here and say that my alpha plus what? Beta is given as what? Minus what? B minus 6 all over what? 2 is given as this. Now, having gotten that this is given as this now, we still move on ahead. Then we now come here. Here is my C all over A. And here is my 5 over what? 2. And of course, you know that when you come here, this alpha beta is product is talking about this 5 over what? 2. Because this alpha plus beta is talking about sum, which is what gave this one. So this one is talking about what? Product, which is alpha beta. And that product agrees with this term C over A, which equally agrees with the 5 over what? 2. So we now say therefore that alpha what beta is given as 5/2. You have 5/2. Okay, it is at this point in time that you can come and talk about the LCM of this and what this. If you now say LCM of this and this, which is alpha what beta, then you now use it now. So you now have that what LCM of this and this is. You have that alpha beta this way. So here you now say alpha beta divided by alpha will give us beta. Beta times this will give me beta squared. Beta squared. The sign here is plus. My alpha beta divided by beta will give me alpha. Alpha multiplied this by will give me alpha squared. And of course, this thing you are seeing here has been expressed. This thing you are seeing here, the numerator can be expressed as, the numerator alone can be expressed as what? Alpha or what? So beta plus alpha all raised to power 2 minus 2 alpha beta. The numerator can be expressed this all over what? Alpha beta. And now you have solved your alpha beta and you have gotten your alpha beta to be minus 6 over what? Over 2. So what you are going to do is to quickly come here. This becomes, in place of this beta plus alpha, and it is important to note that beta plus alpha and alpha plus beta are the same thing. And you have gotten the value to be minus 6 over 2. So here you have minus 6 all over 2, all raised to power 2. Here is my what? 2. Your alpha beta is equally given as 5 over 2. So you say multiply by 5 over what? 2 all over. Your alpha beta still here is 5 over what? 2. That 5 over what? 2. So with your calculating device or whatever thing, you evaluate the value of this thing, and by so doing, you have arrived at the value of that particular problem. You see, it's how to solve this one without having issues. Okay? Thank you very much for your audience. Let us see if we can take one more questions. When we take that one more questions, we now know exactly. This one says, and is simple, simpler than even the one we have on the board. This one says, permit me to clear the board. Permit me to clear the board. So this one says, and I write, say, if the roots of this and this, if alpha and beta are the roots of, here I have 2x raised to power 2 plus 5x plus 5x plus 5x, then plus 3 equals 0. Then what is the value? What is the value of alpha raised to power 2 plus beta raised to power 2? This one is very simple because it's even part of what we already had explained here. For you to solve this one, you just put for yourself solution. Try and change this to look like this. So you have what? 2x raised to power 2 all over 2 plus 5x all over 2 plus 3 all over 2 equals 0. So that this can cancel this. So you have x raised to power 2 plus 5 what? X all over 2, then plus 3 all over 2 equals 0. So you begin that your term by term comparison. This to this, then this to this. This to this means that you are now comparing this with this, which of course you have known that when you compare this with this x will cancel this x, so that alpha beta will become minus b all over a. So that what you are going to have that place becomes what? That alpha plus what? Beta is going to give you what? Minus b all over what? A. And then when you now come here, you'll be checking this thing and this thing. This is x raised to power 2, this is x raised to power 2. This is my x here. This is my x here. The quotient of x here is what? B all over a. And then the quotient of x here is what? 5 over what? 2. So this my b over a here is what we have here, 5 over what? 2. Okay, so in that case, what we are now going to have here becomes what? What we call be that thing is what we have here is what 5/2. So it become, and there is minus here, so you have minus what 5/2. Okay, so then you now come and compare this with this and equally with that. What you have here is what 3/2, which is of course C/A, which is that your alpha beta. So you now see that your alpha beta is given as 3/2. 3/2. So with this, you know that this can be expressed as this numerator. You already know your alpha beta, which is this, which you can plug into this place now, and then you square it direct. And then you already know what this one is, which you can equally plug here. Look at the value here, and then you can evaluate with ease. Okay, there is something I would want you to cross check for me, because I wouldn't know whether when I was solving this very question, whether I consider this minus that is here. So you that have listened for to me all this while, check whether I consider this negative here, because I'm seeing minus 6 here over 2, which I want to believe that if I didn't consider it, it means that here is going to be minus minus. And if it becomes minus minus, it's plus, which of course will not change the value of anything, because this is going to be raised to power 2. Thank you very much for your attention today, and stay put for our next classes. Thank you very much.